Suppose a point moves along a circle of radius r, and the ray from the center of the circle to the point traverses theta radians in time t. Let s equal r theta, we'll remember that for later, be the distance the point travels in time t. Then the speed of the object is given by these two formulas. Omega equals theta over t, which is the angular speed, and v equals s over t, which is the linear speed. And just make sure you know and remember that theta is in radians. So whatever we have, we got to convert it to radian measurements. So let's look at the question. A boy rotates a stone in a 3-foot long sling at a rate of 15 revolutions every 10 seconds. Find the angular and linear velocities of the stone. So angular speed is up here first, so let's do that one first. So we're going to use the formula omega equals theta over t. So we need to know what theta is and what t is. T is easy. Every 10 seconds. So t equals 10. Simple and easy. Now we need to find theta. Well, theta can be found from this point right here. 15 revolutions. So that means it goes in a circle 15 times. So we're going to convert that into radians. And we know that one revolution is 2 pi. And this boy does it 15 times. So 2 pi times 15, which will be 30 pi. So now I have theta right here, 30 pi, and I know t, 10. So I can now plug it in here to get my angular speed. So omega equals theta over t, and that's just going to give me 30 pi over 10. And this is just going to be simplified down to 3 pi radians per second. We use per second because that's what t is in. T is in seconds. And we say 3 pi radians because that is what the central angle is changing for the angular speed. Now let's find the linear speed. So linear speed, we need s over t. And as you can see here, I don't have s shown at all. But remember what I said earlier, we'll need this for later. S is equal to r theta. So that's what we're going to use to find s here. So s equals r theta. And we know that the boy rotates a stone in a 3-foot long sling. So that means with the boy being at the center, the sling is 3 feet out going in a circle. So that is your radius here. So 3. And I'll put feet in so we know 3 feet. And we know theta from up here, 30 pi. Nice and easy. So theta is equal to 30 pi. So we can plug this in to get s. So it's going to be 3 times 30 pi, which will be 90 pi. So we now know s, and we know t because it's the last part we need for this formula, and t is every 10 seconds. So t equals 10 seconds. And so v equals s over t, which is just going to be 90 pi over 10. And then simplify that down, it's just going to be 9 pi feet per second. So the linear speed of this boy throwing a rock out of a sling is 9 pi feet per second. So that is the angular and linear speed for this question.